Hey, what's up coders, hope you are doing well. Today we are using the Chart.js library in order to graphically present poll results. Visualizing data makes it easier for the user to understand information. There are many data visualization JavaScript libraries. Chart.js is one of them. It is a very popular open source library, and for a good reason, since it is simple to use yet flexible. Lightweight, reliable, free, no watermark, not even attribution is needed, and it allows us to create clean, elegant, and responsive charts using the HTML5 Canvas element. Documentation is great as well. So overall, I think that Chart.js can be a great charting choice. I like it so much that I would even paraphrase the famous line/compliment. You are the CSS to my HTML, to you are the Chart.js to my data. In our example, we are hard-coding the data. We are not getting or posting data to some database. This is beyond the scope of this tutorial. The main objective today is to show how we can use the Chart.js library in order to present data, in our case, poll results. I hope you guys will enjoy this video. Don't forget to share, like, subscribe, and without further ado, let's go! Okay, starting with an empty project in our Visual Studio Code editor, let's create the index.html, style.css, and main.js files. In the index.html file, I type exclamation mark, says Emmet abbreviation. VS Code comes with the Emmet plugin embedded, and if I hit tab or enter, we get some HTML5 boilerplate code. Let's insert the title, poll results with Chart.js, and let's link the external files to the document. First, the style sheet. Here we are. And the JavaScript file. Main.js. Notice that instead of placing the script in the body right above the closing body tag, I placed it in the head using the defer attribute so that the script will be executed when the page has finished parsing. Next, let's import the Chart.js library into our project using a CDN. This is the minified JavaScript file, so let's copy the URL and place the script here before the main.js script, again using the defer attribute. Now let's specify content for the body. For starters, we will simply add an h1 heading with the title and a canvas element for the chart. Let's just copy and paste this. And instead of setting the canvas ID to my chart, let's simply set it to chart. Okay, let's open the project in the browser. For this purpose, I'm using the live server, which is a Visual Studio Code extension. So this is what we've created up to this point. We can't see the canvas element, however, it should be here. So if we inspect, here it is, the canvas element with ID chart and 400 pixels width and height. Now, before actually creating the chart with the help of the Chart.js library, let's add some basic styling with CSS. I will just paste this part since it is general styling not directly related to the main objective of this video, so we are setting margin and padding to 0 and box sizing to border box for all elements. For the body, we set font family to Comic Sans MS. I thought this would make sense since the poll is about favorite superheroes. Cursive and sans serif are the fallback font families. We also set background color and color for the body, and for the h1 heading we set text align to center and some margin. We will not style the canvas element eventually, however for now, let's set its border to 3 pixels, solid, and blue just in order to be able to see the area it occupies. Okay, so this is the result of our styling, and now let's move on to our JavaScript file in order to create the chart. As a starting point, let's use the example from documentation from the introduction section. And let's replace var with const. So we are selecting the element with ID chart. This is the canvas element for the chart, and call the getContext method over it with 2D as an argument. This returns an object that provides methods and properties for drawing on the canvas, which we store into this variable ctx, and we then create a new chart using the Chart.js library, passing ctx as the first argument and the configuration object as the second argument. We will come back to this of course in a bit, but first let's save and check the result after changing the name of the chart to Paul chart instead of my chart. Indeed, we get the chart. However, the chart canvas should have 400 pixels width and height. What's happening here? Well, that's because in order to achieve responsiveness for the chart canvas element, Chart.js uses its parent container to update the canvas render and display sizes. In our example, currently the parent container is the body, so in order to control sizing while maintaining responsiveness, we should use a container element relatively positioned and dedicated to the chart canvas only. Responsiveness can then be achieved by setting relative values for the container size. And here is an example. So let's include our chart canvas within a container element. And in our CSS file, let's set position for chart container to relative. We should do this according to documentation, although everything seems to be working fine without it as well. And let's set width to 45% of viewport width. Very nice, and in order to center it horizontally, let's also set margin to auto. Okay, now let's inspect. And we can see that canvas is square with width and height 864 pixels. But why is that? Where did we specify width to height ratio? Is this the default behavior? For example, in addition to setting width for chart container, let's also set height to 22.5 viewport width, so that width of chart container is twice its height. In other words, width to height ratio is 2:1. Let's save and check the result. As we can see, setting the container's height doesn't have any impact in aspect ratio. So chart canvas will respond to the width of its container. However, aspect ratio is defined over the canvas element itself. Currently, aspect ratio is set to 1, and that's why we get a square chart. If, for example, we set height to 300, then we get an aspect ratio of 4:3. Or if we set it to 200, then we get an aspect ratio of 4:2 or 2:1. So if we inspect, indeed, width is 864 pixels and height 432, aspect ratio 2:1. Note that by default Chart.js sets aspect ratio to 2:1. So if we don't explicitly specify aspect ratio, we expect it to be 2:1. Let's confirm. Looks okay, and if we inspect, Again, width is 864 and height 432, aspect ratio 2:1. And by the way, I think the default width is 300 and height 150. Alternatively, we could specify aspect ratio in the chart configuration object here in the options field. Let's set aspect ratio to 1 in order to get a square canvas. Okay, just keep in mind that by explicitly specifying aspect ratio here, we override the configuration setting. As a final note regarding sizing, according to chart canvas aspect ratio, we can set the height for chart container. In our example, this would do since aspect ratio is 2:1, so that it takes up the required for the chart space on the page, for example, while fetching data, so that subsequent content doesn't have to move as soon as the chart is created. And we don't want this anymore. Okay, now let's move back to our JavaScript file and discuss the chart configuration object. For starters, we observe that it consists of three main fields or first level fields, let's say type, data, and options. In the type field, we specify the chart type. Chart.js currently comes with 8 built-in chart types: line, bar, radar, donut and pie, polar area, bubble, and scatter. Area charts as well as mixed charts are derived from the main chart types. Next main field is data. Here we specify an object with the data-related properties, or fields. I'll be using both terms interchangeably here. And by the way, this is in general how we work with Chart.js. Starting from the main fields, we drill down through nested objects until we get to the property we want to modify. Now, in the data object, we have two main fields, labels and datasets. The labels array specifies the x-axis values. The length of the array defines the length of visible data. For example, if we removed the last three values, then the last 3 bars of the chart would also be removed, despite the fact that data for these labels still exist in the data array. Datasets is an array of objects, each object representing a dataset. Here we only have one dataset for which we set the label, number of votes, the data, of course, which is an array with the corresponding to the label's values. In the case of a bar chart, these are the y-axis values. And we also set background color and border color for each bar and border width. Now let's comment this out and see how our chart would look if we didn't modify them. Okay, so this is the default styling, and now let's uncomment border width and set it to 3. This is in pixels, by the way. Okay, and let's uncomment border color. Nice. And finally, let's set the same background color for all bars. For example, let's set it to black. So let's uncomment this, remove all colors except for the first one, which we will set to 000. And let's set opacity to 0.75. Not exactly what we wanted, only the first bar gets the desired background color. In order to set all bars to the same background color, we shouldn't include it within the array. Much better. For more dataset properties you can specify in a bar chart, feel free to check documentation in the bar charts section. And let's specify one more property, for example, the hover background color, which sets the background color when hovered. And let's set it to black. Alternatively, we could use RGBA with opacity 1. Very nice. And finally, we can use the options field in order to specify how the chart behaves. For example, here, starting from the main options field, we drill down to scales, y-axis, ticks, and set the begin at 0 property to true in order to force the y-axis to start from 0. If, for example, we comment out the options configuration, we can see that y-axis starts from 2, which is the minimum value in our data. And if you are wondering how could we figure this out, don't forget that documentation is our friend. For example, we could find this under axis, Cartesian, linear, tick configuration options. And here is the property we are looking for. Let's see if there is some example that would make our lives easier. Here it is. And all we have to do now is set the begin at 0 property to true in here. Of course, when searching for answers, Google or some other search engine can be of great help, especially for a popular library or framework which has been around for a while, such as Chart.js. There is a very good chance we will quickly get the answers we are looking for. Okay, regarding the legend, notice that by clicking on the legend once, related bars are removed. By clicking again, they are added back. Now, this would make more sense if we had more than one dataset. However, in our example, I think it would be better if we removed it. So, options, legend, display false. Nice. I think now it would be a good time to add and present the poll data. So let's do this. Poll data is an array of objects, each object representing an option. Let's go through the first object and I will paste the rest. So we have the option field. First option is Spider-Man. And the votes field. This is the number of votes. For Spider-Man it is 11. Now we could leave it here and set the chart related colors in the chart configuration object or store the colors array into a separate variable. However, I chose to include the corresponding colors here in the color field as a string with the RGB color value. For Spidey, it is a reddish color. So maybe a more exact variable name would be poll chart data. However, I think poll data is also fine, and let's paste the remaining poll options. After Spider-Man, we have Superman, Batman, Son Goku, Hulk, Wolverine, and other. Okay, let's save and proceed. In order to get the labels array, we will use the map method over poll data in order to loop through each poll option object and extract the option value, ending up with an array of options. Okay, and let's do the same for the data array. This time we want to extract the votes property value, and for background color, extracting the color value. And let's remove border color as well as hover background color. And let's check the result. Nice. Now, if we wanted to add transparency to background color and perhaps use a fully opaque border similar to our initial example, I've created this RGB to RGBA function, which takes the RGB color string as the first argument and the alpha value for opacity as the second argument, and returns the RGBA color string. I will not expand on this since this is actually me just playing. It is completely irrelevant to the main objective of this video. As usual, I will include a link to this project in the description in case you want to have a closer look. And let's use the function here. This should be the first argument, the RGB color. Let's set opacity to 0.25. It works, but I think it's a bit too transparent, so let's increase opacity to 0.75. Okay, now let's also add a title to our chart. So in documentation, let's try and figure out how we can do this. Configuration, title. Here are the title properties we can modify. In order to show the title, we should set the display property to true. We should also set text for the title. Some other properties are font size, font family, font color, padding, etc. And let's see if there is some example. Here it is. So in the options object, we specify the title configuration. Let's copy this part and paste it here. Display property for the title is of course set to true. Text will be favorite superheroes. And let's also set font color to dark gray. Font size to 20 pixels, same as for padding. Okay, let's save and check the result. Nice! And finally, I would like to change the font family for all text in the chart so that it matches the font family of the body. So let's go to documentation, fonts. There are 4 special global settings that can change all of the fonts on the chart. Sounds promising. These options are in chart.defaults.global. The global font settings only apply when more specific options are not included in the configuration object. Great. And here is an example where the global default font color is set. We are interested in setting the default font family. Here it is. And this is the default value, so I suppose we should include font families within quotes. Okay, let's do this. Let's place it here. And let's check the result. Marvelous! Now, before adding the poll, in order to show how we can dynamically update the chart, in our example, as soon as the user submits an answer to the poll, let's quickly go through a few alternative chart types that make sense given our dataset, just in order to show how simple it is to experiment with different charts using Chart.js. For starters, let's set type to horizontal bar, which is a variation of the bar chart. It is actually a vertical bar chart. And this is the result, as simple as that. Again, we have the same issue, this time with x-axis starting from 3, which is the minimum value in our data. And again, all we have to do in order to fix this is to set the begin at 0 property to true, this time for x-axis. Okay, and of course, if we wanted, we could sort and present data in ascending or descending order. Now, let's set this back to Y and change chart type to line. Okay, and I would prefer to remove filling of the area below the line. I would also prefer to have straight lines instead of a curved line. And let's also increase the size for each point. We can do this here in the datasets configuration. I will paste in order to save time, so we are setting the fill property to false in order to remove filling of the area under the line. Line tension to 0 in order to get straight lines. I think default is 0.4. Point radius to 10. Default is 3, and point hover radius to 12, default is 4, in order to increase point size. So let's save and check the result. Very nice. There are of course many things you could change and customize the chart according to your needs. We are just scratching the surface here. Now let's remove this line related configuration and change the chart type to pie. Looks good. Nice out-of-the-box animation as well. Animations are of course also configurable. First thing I would like to fix is to remove these grid lines in y-axis, and all we have to do is to remove this part, the scales configuration, in the options object. I will just comment it out since we will eventually need it for our bar chart. Much better. Now in this type of chart it would also make sense to display the legend, allowing for the labels to be displayed. Nice, and let's reposition the legend, for example positioning it to the right. And let's increase padding for labels to 20 pixels. Default I think is 10. Okay, now if for example we cancel the option other by clicking on it, then its percentage is redistributed to remaining options. For example, Superman and Wolverine have 8 votes each. So if only these two options are left, then each gets 50% of the pie. And let's move on to donut chart, which is basically a pie chart with a hole in the middle. Spelling the word donut is probably the hardest part here. Voila! Nothing really to add here, so let's move on to the next chart type, the last we are presenting today, polar area. Here it is. Polar area charts are similar to pie charts, but each segment has the same angle, and what differs is the radius of the segment depending on the value. For example, if we only had Spider-Man, Hulk, and Wolverine, then we can see that each segment has the same angle, in this case 120 degrees, and what differs is the radius depending on the value. In other words, with polar area, we are comparing data through differences in length, while with pie charts through differences in angle. Okay, let's not expand any further. There are also other chart types such as radar or bubble, which are great for visualizing certain datasets. Feel free to experiment. Now, let's remove changes and continue with our main example. So, up to this point, we've created the chart according to current data. But what if we wanted to update the chart after it has been created as soon as data changes? Chart.js makes it quite simple to update the chart, animating to the new data values. In order to demonstrate this, we will create a poll allowing the user to vote for an option and update the chart as soon as the new vote is submitted. So let's move back to our HTML file and add the markup for the poll. Note in here, this is the chart container. I will paste this part. So, poll consists of three main parts: poll heading for the title, poll body for the list of options, and poll footer for the vote button to submit the selected option. We are using radio buttons for the options. All options share the same name, poll options, and of course the value attribute defines the unique value associated with each radio button. This is the value we are going to extract upon submission, and it should be the same as the option field value of poll data objects, since by matching these values after submitting, we will know which option was selected and proceed to updating the vote field value for that option. Okay, and although we are not actually sending data anywhere, let's include the poll within a form, just in order to be semantically correct. Form will have the ID poll form. We don't need the action attribute. And now this button becomes the form submit button, so let's set its type attribute to submit. Back to browser. Here is the poll, and let's add some styling. So let's move back to our CSS file. I will paste styling for the poll in order to accelerate and focus on the main task, which is to update the chart upon poll submission. Again, you can find a link to this project in the description. So we are styling the poll container element and poll heading and poll body with its list and list items and labels, and the poll footer with its button. We are also adding some basic responsiveness. Just notice regarding chart container that while screen size decreases, we increase the width percentage and correspondingly the height, maintaining the 2:1 ratio. Okay, let's save and proceed. This is the poll after styling, and our final goal is to update the chart after submitting an option. For example, if we choose Superman and submit clicking the vote button, we want the corresponding bar to get from 8 to 9. Currently, of course, form is submitted to the current page, since we didn't set a value for the action attribute, and form data is appended into the URL as a name-value pair. Not exactly what we want. And that's why we will prevent the default behavior from happening and manually handle poll form submission with JavaScript. So let's move on to our JavaScript file. And for starters, let's get the poll form element and store it into a variable for easier access. For this purpose, we can use the query selector method. In here goes the CSS selector. Next, we will add an event listener to the poll form element for the submit event. And whenever poll form is submitted, we want to call the poll form submit function. We will implement this function right now. First thing we want to do is to prevent the default action from happening, in this case form submission. And then we want to access the selected option, or in other words, the selected input radio button, and store it into a variable. Starting from poll form, since we are looking for a poll form descendant element, again we are using the query selector method, and selector is input with the name attribute equal to poll options, and with the pseudo class checked present in order to get the selected option. Now we only want to proceed if indeed some option was selected, and in this case we want to get the actual value of the selected radio button input and store it into a variable. And given the selected option, we can find the corresponding object in poll data and update its votes field. So let's do this. And finally, in order to update the chart, we can set the data array in datasets to the updated data. And call the update method over the chart. So this is in general how we can update a chart with Chart.js. First we change the data array and then we call the update method over the chart. Now regarding the data array, we could alternatively get the index of selected option and simply change the specific data point, given of course that poll data and chart data maintain the same order. Or in the case of a new data point, we could use the push method. The same of course stands for the labels array, the background color array, etc. Okay, let's save and check the result. Let's vote for Superman, who currently has 8 votes. Watch the blue bar I'm submitting right now. Indeed, the corresponding bar gets from 8 to 9 with a smooth animation. Thank you, Chart.js. And if we check the console, no errors in the console. Let's also vote for Son Goku. Watch the orange bar. Nice. And for Hulk, green bar. Again and again and again. Obviously we have unlimited number of votes, and if we refresh the page, all changes are lost since we are not actually sending and storing data to some database. I suppose we could reset poll form after submission just for presentational purposes. And all we have to do is to call the reset method over the poll form. Or alternatively, since we only have a radio button group, we could set the checked property of the selected option to false. Okay guys, we are done. I hope by now you feel confident enough to start using Chart.js and incorporate it into your projects in order to visualize data, if of course it fits your needs. This was of course just an overview and by no means an exhaustive walkthrough of Chart.js documentation and capabilities. If you enjoyed this video and got some value out of it, please hit the like button and share it with anyone who might be interested. Don't forget to subscribe if you want more. I would love to hear your thoughts in the comments section below. Until next time, keep coding, keep improving, and enjoy the journey. Take care. Bye.